So let's understand a concept called projection in this section. So let me explain you what a projection is. Let's assume I have a vector A and I have a vector B, and the angle between both of them is, let's say, theta, right? A projection of a vector A onto a vector B is nothing but you take this vector and make it perpendicularly fall on B, and this distance D is nothing but the projection of A on B, right? So basically you have a vector, you let it fall onto vector B. That's what you're projecting A, or you're letting A fall onto B, and the distance that you get on B is called the projection of A on B, right? So the projection of vector A onto vector B is nothing but, so geometrically, let's see, is nothing but D here. And what is D? If the length of this is A, if this length is A, and if this is theta, we know that D is nothing but A cos theta, right? And now we also know, so this is, let's call it equation 1. We also know that A dot B, which is nothing but summation over AI BI over all I, if A is an n-dimensional vector. That's why I don't put any axis here. A and B could be any dimensional vectors here. This is what A dot B is. A dot B also is A multiplied by length of B multiplied by cos theta. So I can write my D as nothing but A dot B by length of B. What is this? This is nothing but length of A, length of B, cos theta by length of B. And length of B would cancel out, and what I get is nothing but length of A multiplied by cos theta, which is nothing but your D from equation 1, right? So you can get a projection of A onto B, which is nothing but your D, as A dot B by length of B. So without even knowing what theta is, if you just know the components of A, A1, A2, so on and so forth, AN, and if you know the components of B, which are B1, B2, so on and so forth, Bn, I can compute what is the projection of a point A onto, of a vector A onto another vector B by just doing A dot B by length of B. So this is a very simple idea which will be very useful in more advanced ideas that we'll learn soon. The next idea is something called a unit vector. Let's understand what is a unit vector. It's a very, very simple concept. Let's assume, again, I'll draw two-dimensional data set, two-dimensional space here, or two-dimensional coordinate system here. Let's assume I have a vector A. Okay, should not tilt like this, it should be a straight line. Okay, so which has two components, A1 and A2, right? So a unit vector is represented with A. So the unit vector is often represented with a cap. This is called a hat or a cap. It looks like a small hat that you can wear on top of it. Is nothing but, okay, let me write the formula, then I'll explain you what it is. It is A by length of A. Now we know that this is the length of A. This is the length of A. So intuitively, a unit vector is nothing but, it's a vector. It's a vector in the same direction, as my original vector. It's in the same direction as my original vector A. So this green line is my A hat. It's in the same direction. That's important to know. So A dash is in the same direction as vector A, number 1. Number 2 is, since you are dividing the vector A by length of A, the length of unit vector is 1. Because what are we doing? We're taking the whole vector, we are dividing it by its length, which means the length of your unit vector will be 1. Right? So this is the concept of a unit vector. This will come in very handy when we learn more advanced concepts of linear algebra. I've just defined some simple terms here.